everyone's ready. Are you ready? Are you ready? I was born ready. Always ready. All right, let's see. Class.
Yes.
Thank you for pretending like you want to be here. Makes life easier, right? Okay. So if you keep pretending, at some point that you'll forget to keep pretending. And you're like, hey, it's actually enjoy. I don't have to pretend. Anyway, so continuity. So continuity, it has to do with, is it continuous? Is the graph going to be continuous? So some of the things are going to be types of functions that you've actually probably have never dealt with. Anyone actually know how to do a step function? A floor function? Okay, so, you know it's funny because I actually never dealt with any of those until I got to calculus. And it's supposed to be like an algebra or a, type of thing. Anyway, so, continuity at a number. That's asking if it is continuous at a number. F of C is defined, that is that C is in the domain of F. Right here, the limit exists. Now, for a limit to exist, what has to happen? Left or right, go to the same point, okay? And this last one right here, F of C, so the function is also equal to the limit. So when you plug in that number, you're going to get what the limit actually is too. So some of these graphs aren't very clear, so I'm going to... Okay, so this right here, this is the left side is equal to the right side was equal to F of C. So left side, right side, F of C, solid dot right there. That makes sense? Okay, next one. Left side equal to the right side, it's not equal to here. So left side, right side, F of C is way down here. So that's a perfect example of that. It's almost like I'm giving you guys notes to write into your notebook or your notes that I gave you and print it out. But next one. Next one here, left side is equal to the right side. And F of C is undefined. That means there is nowhere. That is an asymptote. Not an asymptote. That is a hole. Sorry. That's a hole. We'll get into asymptotes later. So that's going to be a hole right there. So at that singular point, it is undefined. There's an open dot there. Nowhere at that function C is it defined. So it's always undefined there. So that if you notice right here, this one over here it is defined, but it's not at that same point. This one, it is undefined at no matter what C is. Okay, next one. Left side, right side. These are not equal. So think of this as a roller coaster. Okay, any of you guys been on a roller coaster? Yeah? Okay. Tree? Roller coaster? Yeah, okay. So, the idea of a roller coaster. Do you want the track of that roller coaster on to be continuous? Yes, you do. So, think of it like that. Continuous is a roller coaster track. Can you have any holes? No. No holes in the track. Okay, can you have any jumps? No jumps in the track. This, in that roller coaster, is a jump. So it is not going to be continuous because they're going, the left side and right side are going somewhere else. But this one says it is also defined at this point down here. Here's another example, my roller coaster. Bam, bam, left side, right side. And now, if you notice, it's also a jump. They're not going to the same point. So the left side is not equal to the right side. So I'm going through my list. Okay, it is continuous if the following three conditions are met. Okay, it is defined. Okay, here's a undefined. Here is also another undefined. The limit exists. Left hand, right hand go to the same number, and it has to. The limit is equal to the function. So the only one that is actually going to work is this one here. Make sense? Determine whether a function is continuous at a number. Do we have to do the whole thing? Say no. Can I look at it and use my mental math to think about it? So, as this one right here, I want to look for restrictions on the domain. There's two things that I've already mentioned in this class that we cannot have. We cannot have imaginary. So I cannot have an even root. The other day I actually mentioned it as a square root, but it's going to be any even root, because we're going to deal with some fourth root, some sixth root, some eighth root. Any of the even roots, you cannot have a negative number inside there. But can I have the cube root of negative 8? Yes, because to get the cube root, it's negative 2 times negative 2 times negative 2. That's going to give me my negative 8. So it is specific to the nth root, okay, where it is a even number. I cannot have even numbers there. So inside there, I cannot have negatives. That would be the imaginaries. What is the other type that I've mentioned this last week? Only Chuck Norris could do it. Divide by 0, right? Can't divide by 0. So we're looking at restrictions to this domain. Does this have any properties which has a radical? No. Does this have any properties that there is a quotient here? There is a denominator? No. So I don't have any restrictions. So is it continuous? Yeah. Because there is no restrictions that would give me undefined. That is going to give me holes. That is going to give me those things in which I cannot have. So, is it continuous? Yes. Now, B. B, I'm going to have some restrictions. I am. Because this one has a denominator, and there is a variable in the denominator. If I had something like x squared over 4, would that count as a restriction? It's a fraction, right? It has a denominator. So, but that would not work. I have to look for variables in the denominator. This one here, x squared plus 9 over x squared minus 4. To be able to find that restrictions, I would have to do what? I could do it two different ways. What are my two ways? Set it equal to 0. Set my denominator equal to 0. So I could say x squared minus 4 equals 0. Okay, I can do that. Okay, so that would help me out by going through, because I want to know where it's going to be equal to 0. What else could I have done? Could I factored it and done the same thing from here? Yeah. This, I would go through, add 4 to both sides. X squared is equal to 4. And how do I undo a square? Square root. But if I'm doing a square root, what can I not forget? And that's the reason why I kind of frown upon this, because a lot of people forget. If you're taking the square root, what do you have to include? Plus or minus. Because right here, there is a possibility, and a lot of students forget about this, that I'm taking the square root of both sides. That means that there's a possibility x equals plus or minus the square root of 4. So that means that my places in which that it is going to be equal to 0 would be x equals plus and minus 2. So that's one way of doing it. Now, the other way, I would write it as x squared plus 9 over x plus 2, x minus 2. I think the factoring way actually is a little bit more, because that step right there, that's what gets like 90% of people are going to get that part right there, and they forget. Now, this next way of doing this is called the zero product rule. 0 is the perfect number. 0 takes away, clears out. It actually, mathematically, society did not start evolving until there was an identity of 0. Until they discovered 0. That's weird, right? They need mathematically a symbol to symbolize nothing. Zero product rule, anything times 0 is 0. That's important. Anything times 0 is 0. So right here, let's just look at this piece right here. What number for x would make that equal to 0? That would be a -2, right? What number for x would make this one here be 0? Okay, so that would be a +2. So if I plug in a +2, this would be a 0 times 2 plus 2, 4. But anything times 0 is 0. So that's the reason why I kind of like this way. So I factor it and I see each one individually. Make sense? Yeah. So, given that, either way, is this going to be is it going to be continuous at +2? You say no? Okay. We know because both places are saying positive -2, I get 0 in the denominator. Positive -2, I get 0 in the denominator. For this to be continuous, what was the second thing that I said had to happen? Has to have a limit, right? And the definition of a limit that I keep saying over and over again, for it to be a limit, what has to happen? Both sides. Now, both sides. If I were to graph this, can I have numbers less than 2? Can I put in 1? Okay. All right. Right there. Okay. If I plug in 3, yeah, that one it would work too. But my problem comes in when my limit is not equal to the function. Because at the function here, I get undefined. So if I go back to my graph, it's going to look like this one here. My left side and right side are going to go to a number, and right there at that number, it is undefined. All right, determine whether a function is continuous at a number. Determine, is it continuous at numbers -2, 0, and 2? Start with restrictions. Looking at the function, this one has both the restrictions that we're talking about. So on the bottom, I would have x plus 2, x minus 2. So because of those restrictions, I'd say that x cannot be equal to 2 or negative 2. Okay, that's a good start. My other restriction is a square root. So it's going to say the square root of x squared plus 2. And I know here that it's got to be greater than 0. Can it be less than 0? No. I can plug in a whole bunch of numbers, but I cannot plug in anything that would make it less than 0. So my restriction on this is going to look slightly different. I'm going to say that the inside of this, right here, so all this here has to be greater than or equal to 0. Because can my radical equal 0? Can I have the square root of 0? Okay, so I can have the square root of 0. Okay, so now I'm going to do the math on this one now. So, square both sides. X has to be greater than or equal to plus or minus square root of 2. So in my restrictions there, plus or minus square root of 2. So if we want to evaluate this numerically, because this might look kind of weird, what is square root of 2? Like 1.3, right? Well, yeah, 1.4. Okay, so if I put in a positive 1.4, let's pull up my calculator. Yeah, again, I'm sorry, I have to use the other calculator. You guys have a better calculator right now. I have to install it here because I don't have it. Is it plus 2 or minus 2? Plus, okay. Over x squared minus 4, right? Okay. The graph. Okay, let's see what the table says. Oh yeah, keep forgetting that it's not. So as we're looking at this, looking at my table, let's say, let's go into negatives. So negative 2. Okay, negative 2 is undefined. Negative 3. Okay, so right now, I get at negative 2, that's going to give me undefined. Negative 3, I get this number here. At positive 2, get undefined. What about 0? Okay, at 0, I get a number here too, right? All right, so I keep going. And what was the other restriction I had? So, plus or minus square root, so go up. At 0, it does work. At -2, it does work. At +2, right here, it doesn't work. I said doesn't, right? Or did I say does for negative? Yeah, okay. So right here, so what we're dealing with is we're dealing with a small area, and then inside the radical, I have a problem, but because there is a square there, it has to be certain numbers. So because of this, I had problems, but as I plug in any numbers, can I have any numbers here that I plug in that's going to give me any issues? If I plug in any numbers, what do I get? I'm going to get positive, right? So is it possible to get a negative right there? How? I could plug in a square root. What if I plug in a square root of -2? Or square root of -4? Would that work? Because that's already imaginary, right? Yeah, if you're squaring imaginary number to take it back to a real number, and then that would be y. So because of this, I don't have any real restrictions on this. That's why when I'm looking at these things here, I'm looking at both. I look to see that this right here has to be greater than or equal to 0. Yes, I did some math for this one. And I look at this. Is there any place here in which that it's going to become a negative? No. So there is nowhere to make it a negative, so that's important. Check your work. Check your answers. Go back through. Plug it in. So when we plug this in, it didn't work. It clearly did not work. If I plug these in, did it work? Yes, it did. So because there's no restrictions here, that is going to make any of these become negative. You're going to square whatever it is, so I can't have a negative in there. If this was a -2, that would be a big difference. If it was a -2, it would change a lot. That's going to change a lot. If it was a -2, all this goes away as part of that. Because that would give me problems that are inside here that would be part of that radical, which would give me negatives. Does that make sense, or is that nonsense? Okay. All right, back to the notes. Okay, we're checking all the work. Checking it twice. There you go. So, I'm going to leave off here. And we're going to pick this up again tomorrow. So, the homework problems for you guys are going to be right here. Oh, there should be, I didn't change the objective. I'm sorry. So, yeah, it's 1.3. I changed the homework, but I forgot to change the objective. All right. Make sure you all like, share, and subscribe. Hit that notification button. And use this time wisely, not to just stare at your phone.